Hello everyone and welcome back. So with this session we're gonna go through the command line interface, explore how to interact with the command line, execute various commands, see what are the different command line modes that we have with BigIB. The first one called the Linux shell, or what F5 call advanced shell. This is where you execute Linux commands. So any command that you use to, not any, most of the commands that you use to execute when on Linux shell, you will be able to execute here. So for example, if you want to check the NTP, if the BigIB is already in sync with the NTP server, you can say NTPQ minus PN. Check the routing table, let's stat minus R. Do telnet as we did previously. We telnet to one of the pool members on port 80. You can do ping, you can do um, all, I would say most of the required commands to do test and verification. Um, The other mode is the TMOS mode, the Traffic Management Operating System. TMOS is the F5 operating system that makes the BigIB. So they call it TMOS or TMSH. Now, let's go to the command line. When you first land on the BigIB, you are in config mode. This is the Linux shell mode. To move to F5 mode, you say TMSH. So you are in TMOS mode. To go back, we say quit. So we go back, net stat minus R. Check the routing table for the BigIB, and I want you to emphasize here on this is the Linux routing table, which is the management routing table. This routing table is the routing table for the management interface for the Linux, the management routing table. That's why you see the default gateway of the management. That's why you see the management subnet. You see also the inside and you see also the outside. Now, if I go to the GUI, if you go to System, Platform, this is our management default route, management gateway, if you remember. So over the management interface, if I want to reach other subnets other than my management subnet, I will use this as a default gateway. This is actually what you see here on the command line. Now, this is the Linux routing table. If I want to see the BigIB routing table, I have to go to TMSH and I say list /LTM because we have LTM, AFM, different software modules. So we're specifying here, I want to see the LTM routing table. Sorry, we have to say /net, not. So break here. To see the BigIB routing table, not the Linux routing table, we have to go into TMOS mode and say now to see the TMOS routing table, not the Linux management routing table, we have to go to the TMSH and say list /network route. Show me the route. There is no route. I can confirm this if we go to the GUI, to the network routes. Currently there are no routes. Let's just add a testing route. Test. Destination is 172.1.1.0/24. We use the gateway. Let's assume it's on the outside, 192.168.100.1. Sorry, .1 is the BigIB interface, so .254 is the gateway on the outside interface. Click finish. So we have a route here on the big IP. Now if I go back to the command line, I say list route, you can see the route now appear. Now if we quit, go back and net stat minus R to see the Linux routing table again. It's taking time. We can see that the route is added to the Linux routing table and the TMOS. So the big IP routes, those routes that we configure here, they will show on both the TMOS routing table and the Linux routing table. However, inside the big IP TMOS OS, if you say list net route, you will not see the management routes. You will see only the routes that are related to the big IP. So that's why we will always emphasize on there are two routing tables. One routing table for the data, for the TMOS, and one routing table for the management, which is the Linux routing table. We will explain in more details in a later slide, but just wanted to show this from a command line perspective. As we said, we can ping server 1. You remember the firewall is activated, so we can ping server 2. Now, from the Linux command line, you can still interact with the TMOS commands, but you have to say tmsh. So you are prepending the command with the keyword tmsh list/net route. Now, without tmsh, if you are in the Linux shell, try to execute F5 command, it will fail because it's not a Linux command. But once you prepend, you are telling the command line execute this inside the TMOS, and it's there. But what is the disadvantage is you lose the help here. So if I am in tmsh, I say li tab, it will complete /net tab double tab, you get all the possibilities. So you can say route. Now, if we go back to the Linux, even if you say tmsh list, there is no tab completion. I am pressing tab. It's not completing. So you have to know the command exactly to execute it. While inside the TMOS, you will get help, auto completion, and what are the possibilities as arguments. So this is one of the difference of running a TMOS command inside TMOS or from Linux shell. Let's check the pools. So we can say list LTM pool. We know that we have a pool, 3 servers. This is the name, this is the port 80, this is the IP address. You see even the priority group, state is up, so monitor is enabled. There is a health check. You can do that in a different way. So you can say I want to go into LTM sub mode. So now you type LTM, we are in tmos.ltm. Then I want to go into pool. So you are inside TMOS LTM pool. Now you can say list. You get the same output. You get the same output. You can exit. I can say list LTM virtual server. So this is our virtual server. All the configuration related to the virtual server. Again, I can say LTM virtual list. Same output. Now, we said list LTM pool. So we got the configuration. If you say show LTM pool, you get the operational status. The pool is available, it is enabled, current active members, available members, the traffic in and out, etc., etc. So you get the operational status, show. There is a difference between show and list. It's if you're coming from Cisco background, it's like show interface or show run interface. It's kind of the same concept here. I think we covered most of the things that we wanted to cover. Yeah. If you want to create, you can use the command create /ltm pool test, delete pool test as well. So same concept. Now, connections, seeing the connection and the connection timeout. This is actually very handy when it comes to troubleshooting on big IB to check the current connections or the connection table. Let's go through the command. So show /sys connection. This is the base of the command. Now, after that, you may have any of these arguments. Remember, we have client side and we have server side. With big IB, from client to virtual server, this is client side. From big IB to our pool members or nodes, this is a server side. So you want to see the connections. So let's take an example. Let's run our testing machine. This testing machine, we said the IP address of our testing machine is 15. It's 192.168.115. So on the big IB, what I can say is show this connection client side client address. Show me the connections related to the client address 192.168.100.15. Zero connections. Okay, let's open a connection. Let's just refresh. Let me close all first. Open again. Yeah, so we have connection going to server 1. If we show connection again, we see that 100.15 hit the virtual server, and then from the server side in the back end, we forwarded the packet from 115 to server number 1, pool member number 1. So this is the timeout of the connection. It will keep counter up and up until it reaches the default timeout. I think it's 600 seconds or 300. Let's check this. local traffic. It should be on profiles, TCP profile, the default TCP profile. Yeah, the idle time of the connection, idle timeout is 300 seconds. So this connection should time out after almost like 3 minutes. So let's wait and see. We can go to the client and refresh. You see, when it's a new connection, chance is very high to hit the different server. But if I refresh, because I'm using the same connection, I will not go to a different server. Let's go back and see. Yeah, we see that now on the server side, it's from testing machine to server 3. And the counter will, for the timeout, will continue to go up. So what else we can use? Because we used client side, client address. We filtered the connections on the client side, client address argument. Now, of course, you can say show sys connection. That will show you the full connection table if you want. But we usually filter based on some criteria. I can say client side server address. What is the server address on the client side? Think about it. What would be the server address on the client side? It's going to be the virtual server IP address, because from client perspective, what is the server? It is the IP address of the virtual server on the big IP. It is the virtual server that the client use to browse the web application. So let's use this argument. Show connection client side server address 192.168.100.80. So we see the same connection. So we have the client .15 accessing the virtual server. What else we can use as an argument? You can use port. We can use server side client address. So server side client address. From server side perspective, what is the client address? It's still the same. It is .15. So I can say show sys connection server side client address 192.168.100.15. No connection just because we need to refresh. And now we have the connection. Now I know it's going to serve node number 3, so I can say server side server address 10.00.83. We have one connection. 82, no connections. 81, no connections. I can try to force it to go, yeah, 82 now. So we can check 82, there is connection. 81, no connection. 83, still there is no connection, timeout. So that's the show connection command. These are the different arguments that we can use. So we've seen the default timeout for the connection. The default TCP connection timeout is 300 seconds. The way we can change this default, whether to increase or to make it less if required by the application team, is using TCP profile. We've seen that the default TCP profile that ships with the big IP, it's already created and we cannot delete it, and it's not recommended to change it. It's always recommend when you want to do some changes on the TCP protocol parameters, we can go and create a new TCP profile, and we select the existing TCP profile, the default one, to be parent. And then on the right side, select which parameter you want to customize. So we select the idle timeout, make it less, and then we click create our profile, and then we go to the virtual server and we attach the profile as protocol profile. So let's see this in action. We should go to profiles, protocol profiles, sorry, TCP. We create, call it our TCP profile. We wanted to customize the timeout. Let's make it 9 seconds so that it expires quickly. These all other TCP parameters that you can customize on Big IP. So we have our TCP profile. Next step is to go to the virtual server and select our TCP profile as protocol profile, and then click update. Now this is the profile. Let's go to our testing machine. Let's refresh. Let's first make sure there are no connections. So let's use show sys connection client side server address 192.168.100.80, the virtual server address, 0 connections. We go back and click refresh. We hit server 1. We can see that we hit server 1. Keep an eye on the timeout. 9, 10, gone. So it's not precisely 9, but the process of cleaning the timed out connections, sometimes it takes some time. It's not happening continuously. So we don't have connection now. We can refresh again. We come to server 2. We see that now we're going to server 2. So the connection should time out soon, which it does. So this is how you change the timeout for the connection table using TCP profile. Now there is 2 timeouts that are related to the connection that will affect the load balancing decision. We have seen now the connection idle timeout, and we have seen previously the persistence record. We should not confuse between both of them, because persistence record means when I have user 1 hit the virtual server and the load balancing algorithm select server 1 to serve user 1, I will create a persistence record that for the next, let's say, 5 minutes, any request coming from user 1, any new connection even coming from user 1, will also go to server 1. Now, we have seen in the testing now, when the connection times out, chances are very high if we refresh, we hit different servers. So once your connection times out, chances are very high that you hit a different server because the load balancing algorithm will be running and select a new server for you. You see, when we test after the connection timeout, chances are very high that you hit a new server. Now we are with server 1. Let's leave it to timeout. We go back, refresh, now on 3. Now within the 9 seconds timeout, connection timeout, if you continue to refresh, chances are very high you are going to the same server. Now we are on server 2. So even if I do refresh, I'm still on server 2. Once the connection timeout, if I leave the connection without activity idle for the timeout, now the connection timed out. Now chances are very high we go to a different server. So when your TCP connection times out, you will go through the load balancing the load balancing method again, the load balancing algorithm. But if you have a persistence record and the persistence timeout is 5 minutes, so you hit the virtual server for the first time, load balancing sends you to server 1. So user 1 is going to server 1. We create persistence record that user 1 will persist with server 1 for 5 minutes. Now user 1 is doing some activity and then he stopped. He stopped for 1 minute. He stopped for 1 minute and our timeout is 30 or 9 seconds. Our timeout is 9 seconds. When user 1 stopped for 1 minute, his TCP connection timed out. So now when he refreshed the application, he's opening a new TCP connection. Now, because there is a persistence record for user 1 that is valid for 5 minutes, user 1 will not go through load balancing algorithm again because user 1 has already persistence record valid for 5 minutes. So the decision will be send user 1 to server 1, even user 1 TCP connection timed out. And let's test this in the lab. We have our TCP timeout is for 3 seconds, for 9 seconds now, and we are seeing it in action when the TCP connection times out and I do refresh, chances are very high that I hit different server. Let's go and create persistence profile. As we have seen it before, our IP persist with source affinity, parent profile source address. Now we can actually leave, so it's 180 seconds. Let's customize this. Let's make it 300. Now we have our persistence profile. Let's go to the virtual server. And the resources, persistence profile, our persistence. Click update. Let's test the persistence first. No connections. Let's open new tab. 192, 168. Yeah, we are with server 1. No, server 3. That was cached page. So our connection, we can confirm from the table, we are with server 3. Now we can see the statistics for the persistence. Persistence records. Break. We can see that we have a record that has been there for 1 minute. User.15 going to server 3. Now, at the same time, continue here. So we can see that there is a persistence record for the user going to server 3. At the same time, if we say show sys connection client side client address 192.168.100.15, this is the IP address of the client. There is no connection. There is no TCP connection, but there is still persistence. So if I hit refresh, I am certainly sure I will continue to go to server 3. Why? As long as this persistence record is in the persistence table, even if my TCP connection time out, I will continue to go to server 3. So the point here is the persistence record says I always go to the same server as long as the persistence timeout not expired. So even my TCP connection timed out, I will continue to go to the same server. Just to confirm one more time, if we remove the persistence profile, none, update, we don't have connection, chances are very high I hit different server now. There you go, we hit server 2.